Good morning, everyone. I am Reinze Vito, Faculty of Pi Department, TUP Manila, and it is my honor to present my research journal, which will tackle about my twofold of expertise, the assessment and technical skills, particularly in technical drafting. As a 21st century teacher, we are all required by our educational institutions to adapt to the ever-changing needs of our students in the teaching-learning process. One of this is applying different teaching techniques and strategies just to make sure that learning is taking place. Thus, performance-based assessment became one of the most effective techniques used by our teachers, especially in industrial and technology education and even in Tibet. However, it is also deemed to be the hardest to facilitate in comparison with other objective or traditional assessments. As cited by Tackwiller 2012, Rosaroso and Rosaroso 2015, and Zhang 2013, the following are considered to be the roadblocks in the conduct of performance-based assessment. First is lack of time in checking, lack of resources for hands-on activities, lack of infrastructures or laboratories. It even requires a complex standardization of scoring procedures or rubrics. It is also prone to human error in comparison to other assessment techniques. Laborious feedback is also required, and we only have short time frame to its conduct. On this regard, several technologies advancements are developed to solve the existing problems in the field of assessment, such as the ZipGrade. It is a mobile application that turns your device into an optical scanner for grading multiple choice assessment. We also have PaperRater, which aids in checking grammar, punctuation, and spelling errors in an essay. So both of these technologies were able to expedite scores, provide quantity and quality feedback in a shorter response time. However, both of these technologies are also not enough to check performance-based assessment. Meanwhile, computer-aided design is a subject in civil engineering in San Diego State University in California, which requires their student to create the same drawing on this example as their performance assessment. Given this complex drawing, it will be so much hard for their professor to rate them and make sure that every portion has been checked. Thus, on the study of Deo in 2010, they were able to come up with an AutoCAD grading application, back-end program, to aid on checking computer-aided engineering drawings. It specifically compares students' drawing to a reference drawing and generates feedback after the completion of each activities. The same program was also enhanced by Corna in 2012 by developing a web-based version of the same program. The following are the gaps identified out of their studies. Number 1, it is strictly point-to-point. Number 2, the time frame for completion and matching of submitted exercises on the quality and expected standards are risky. And then number 3, general grading criteria use the number of entities, their values, and the measurements, which is not how the teachers or the course facilitator checks. Similarly, here in the Philippines, technical drafting is a subject in the K-12 education, which also requires high school students to create engineering drawings in a manual and computer-aided technique in an individual activities. So given the class size we have here in the country, this causes the teachers to have the following identified gaps. They have identified delays in grading, errors in evaluation, very time-consuming, and even improper utilization of resources. So to resolve this issue, it is necessary to use a developed software in checking the drawing plates to come up with a reliable, timely, unbiased scoring and feedback. For this regard, the researcher conducted the study entitled Checking Software for Technical Drafting Plates, Development and Evaluation. This study utilizes an IPO model with inputs such as knowledge, software, and hardware requirements that is processed using Agile software development lifecycle model to develop the checking software for technical drafting plates, which is then evaluated by the respondents. The following are the objectives of this study. Number 1, to design the software that has the following features. 1.1, check drawing plates following detailed scoring rubric. 1.2, display scores and remarks immediately. Number 2, to create the system as designed using the following technologies. And the number 3, to test and improve the developed system in terms of its functionality and portability. And lastly, to evaluate the performance of the system using ISO 25010 software evaluation instrument. So for the scope and limitation, the following advanced technologies were able to be utilized in the study. Furthermore, the minimum system requirements depends on the AutoCAD software to be utilized, or at least 1 GHz or faster processor with 2 GB RAM for 32-bit system, or 4 GB RAM for 64-bit system with a minimum disk space of 4 GB. Basically, the software will try to compare a faculty reference DXF file to the student's DXF file. DXF file is an AutoCAD file extension that can be easily used to save CAD files. Afterwards, the checking software will check the activity using the following scoring criteria: the line technique, accuracy and completeness, annotations, plotting, speed. So those criteria were actually evaluated and validated by the accredited competency assessors in technical drafting. So the study covers 5 core competencies of technical drafting, such as architectural, mechanical, plumbing and sanitary, electrical and electronics, and lastly, the structural. On the testing phase, it was actually conducted by a software quality assurance certified by International Software Testing Qualifications Board. In the testing part, we have two portions: the functionality testing and the portability testing for Windows 7, 8, and 10. And the evaluation phase will be comprised of respondents, 3 accredited Tech NC2 assessors, 2 IT practitioners, 5 Tech NC2 senior high school teachers, and 20 senior high school students. So they are chosen using purposive sampling technique. The project designed to work on a local area network shown by this figure. On the other hand, CSTDP features includes the use of a detailed scoring criteria validated by the assessors in technical drafting. They are considered to be national experts in the assessment of such drawings. Furthermore, it also rates and feedbacks immediately on activities submitted. And it stores previews activities. The program can also be used by the teachers in the project collection, and it provides a detailed verbal and numerical feedback for the students per criteria. The program is also accessible via authentication of username and password of the student and teacher's account. It also has a minimalistic user interface. And lastly, it works with separate faculty account and student account. In the evaluation procedure, ISO 25010 was utilized, which covers the following 8 indicators: the functionality suitability, reliability, portability, usability, performance efficiency, security, compatibility, and maintainability. The results were processed using mean and standard deviation to describe the responses of the participants. The Likert scale shown was used in describing their responses. Let's move on to the test and evaluation results. For the test of functionality, the following are the findings of the study. So for the functional testing, All test cases were passed by the software and even in portability testing. So this means that the application is working as intended and is portable for Windows 7, 8, and 10. The overall evaluation of the respondents gathered 4.80 with a verbal interpretation of outstanding. Moreover, the highest predictor of this functional suitability indicator with mean of 4.93 or outstanding. Conclusions and recommendations. The project was successfully designed such that the system successfully assesses architectural, mechanical, plumbing and sanitary, electrical and electronics, and structural layout and details, which are the competencies of the course. The scoring rubrics was also validated by Test.Tech NC2 assessors with the following criteria: line technique, accuracy, and completeness, annotations, plotting, and speed. It all can be checked and scored by the system. Also, it instantly displays the overall score for the specific plate in percentage format and breaks down this rating with the achieved points for each criterion. Feedbacks are presented in addition to the numeric rating to contribute directly to the progress in learning. Number 2, all advanced technologies mentioned were used in the development of the system. Number 3, the system was tested and improved according to its functionality using test cases and its portability to Windows operating system. The testing results suggest that the software functions excellently and runs entirely on Windows operating systems such as Windows 7, 8, and 10. And lastly, number 4, the system was evaluated using ISO 25010 and acquired a grand mean of 4.80, which implies outstanding. It shows that the checking software for technical drafting plates is recognized by the students, teachers, Tech NC2 assessors, and IT practitioner as an effective and efficient computer-based system for the technical drafting specialization in senior high school. Furthermore, there are also recommendations for its improvement, such as creating a web version of it and adding additional features if possible. And that ends my presentation. Thank you very much for listening and God bless everyone.